Okay, more proofs. And now, if you haven't watched the previous video on proofs, I would recommend you go back and watch that first, because as you'll see, we're actually building up our proofs. So with proofs, what are we doing? We're taking something we know plus something we know, and we find something new. And what we're going to actually do in this example we're going to look at today is going to build on something we know from what we did last time, which is why you need to go back and watch the previous video. Now, we know we're doing a proof because it says prove. And again, we're looking at some words like interior. We know that means inside. And quadrilateral, that means quad, four, and lateral lines. So a quadrilateral is a shape with four lines, like we have over here. That, 2, 3, 4, that's my four lines. And we want to show that they add up to 360 degrees. Okay, we've got quite a lot to fill in here. Let's break that up into little pieces and see if we can take something we know plus something we know and find out something new. So what do we want to do? We want to prove that the interior angles of a quadrilateral, a four-sided shape, we have one over here, looks like a parallelogram to me, add to 360 degrees. All right, now it's always good in these things to actually label things. So this is, I'm going to call this one A, B, C, and D. So what we're saying is that angle A plus angle B plus angle C plus angle D equals 360 degrees. So there's all our four interior angles, and they're all summing, that's the adding part, to 360 degrees. Well, let's see how we can do that. Okay, so first of all, we have our angle A, angle B, angle C, and angle D. Now, with proofs, we got to start with something we know. But from the previous video, we know all about triangles. So first we split the quadrilateral into triangles because that's something we know. Now, if you look at a quadrilateral, any quadrilateral, but this one, we can split that two ways. We can split along here. That's two triangles, or we could have done a split along there, and we would have got two triangles, roughly. So I'm going to choose the orange line to split my shape. So I'm going to split down here, and I've got myself two triangles. But we can say here that the angle B up here, angle B is split. So we're going to give it some new names. We're going to say this part is E and the other half is F. So split into angle E and angle F. And angle D down here, that's been split into two parts. So angle D, doesn't give you much room here, does it? Angle D is split into angle G and angle H. So angle G and angle H. Cool. I'm really running out of room here. I'm going to come down here a bit. So what we're saying now is not angle A plus angle B plus angle C plus angle D. That's what we said before. We know it's angle A plus angle E plus angle F plus angle C plus angle H plus angle G equals 360 degrees. So now we got 6 angles because we got 2 triangles and each triangle has 3 angles. So let's color these things up and we can talk about triangles instead of a quadrilateral now. So this purple triangle, I'm going to write that in purple. That purple triangle is made of angle A plus angle E plus angle G, and then we're adding on to that. Let's do another color. Let's do light blue, and we've got a light blue triangle now over here, and that light blue triangle is angle F plus angle C plus angle H. And we said the whole thing needs to equal 360 degrees. So looking at our purple triangle, we know angle A plus angle E plus angle H equal 180. And looking at the light blue triangle, angle F plus angle C plus angle G equals 180. Therefore, angle A plus angle E plus angle H plus angle F plus angle C plus angle G equals 180 plus 180 equals 360. Thus, we can say what we said before, angle A plus angle B plus angle C plus angle D equals 360 degrees. So what did we do? We took something we know, and that something we know is that a quadrilateral, a four-lined shape, can be cut into two triangles, which is good because the other thing we know is the sum of interior angles of a triangle is 180 degrees. And that then proves something new because two lots of 180 is 360. So the sum of interior angles of a quadrilateral is 360 degrees. Now that's a really good proof because it's building up more and more on previous knowledge, and that's what I like to do with proofs. I prove this thing, I can prove the next thing, and I can build up a nice tower. If you think about it, actually, that any shape can be cut into triangles, and if they can be cut into triangles and we know stuff about triangles, then we know stuff about that shape. Let me just do a little squiggle on the side to show that. So let's just go, there's a shape. And that's got 1, 2, 3, 4, 5, 6 sides. But if I cut it into pieces, now I could cut it into a lot more triangles, but that's the minimum number of triangles we could do. We see we've got 1, 2, 3, 1, 2, 3, 4 triangles. Well, 4 triangles, that means 4 lots of 180, doesn't it? So we know that the sum of the interior angles is going to be 4 lots of 180 degrees, and that's going to equal 720 degrees, and that's for a 6-sided shape. So you can see that this proof can be extended to any odd shape you want to draw.